Okay, let's dive right into this. Welcome to today's Explainer, where we're going to unpack the actual mechanics behind artificial intelligence and machine learning. We're getting way past the buzzwords today, you know. We're going to trace the foundational theory straight through to the algorithms that are quite literally reshaping global industries right now.
Here is our roadmap for today. We'll start off broad by defining artificial intelligence. Then we'll distinguish the machine learning difference, uncover how machines actually learn, map out the machine learning process, and finally look at real-world AI impact.
So, Section 1, Defining Artificial Intelligence. Let's really look at what it means for a machine to simulate intelligence. Before we get completely swept up in modern tech, we've got to remember that AI, it's a decades-long pursuit. It actually goes all the way back to 1950 with Alan Turing and his famous Turing test. And by 1956, we already had the first AI programs like the logic theorist. But, it wasn't a straight shot to the top. The industry went through these brutal AI winters. These were periods where that early hype just vanished and funding completely dried up. But thankfully, computational power finally caught up, bringing us straight into this modern era defined by machine learning.
Moving right along to Section 2, the machine learning difference. Let's zoom in on this specific approach to AI. And this brilliantly illustrates how we should think about these buzzwords. It's basically a giant set of nesting dolls. Artificial intelligence is that outermost shell, a broad program that can sense, reason, act, and adapt. Inside that is machine learning, which uses algorithms that actively improve as they get exposed to more data. And then, nested right at the absolute core, is deep learning, which utilizes complex, multi-layered neural networks.
Let's just clear up a super common misconception right now. AI is the overarching goal, right? It's the dream of getting machines to perform human-level cognitive tasks. Machine learning, on the other hand, is simply a specific, data-driven method used to reach that goal. So instead of explicitly programming a machine to do a task step by step, you feed it data and it actually learns how to do the task itself. It's a total game changer.
But it's important to remember that machine learning isn't acting alone out there. The wider AI ecosystem includes expert systems that mimic human decision-making, natural language processing for understanding speech, robotics for physical autonomy, and computer vision for visual interpretation. So while machine learning is our main focus today, it operates alongside all these other massive subfields.
Okay, let's get under the hood. Section 3, How Machines Actually Learn.
There are really three fundamental ways to train these algorithms. First up is supervised learning, which relies on labeled data. Think of this like giving an algorithm the answer key right alongside the test. Second, we have unsupervised learning. This is where the machine is just given raw, unlabeled information and basically left to find hidden patterns entirely on its own. And third, reinforcement learning, which operates on an environmental reward system. Actually, this is exactly how we train AI to master those insanely complex video games.
Now, to truly grasp all of this, the vocabulary really matters. You start with your data set. Then training is the process of feeding that data into the algorithm. But the absolute crucial output here is the model. The model is the mathematical representation of what the machine has actually learned. And once that model is trained, you put it to work making predictions, which is a process known in the industry as inference.
Let's keep the momentum going with Section 4, the machine learning process. Mapping out the complete machine learning process reveals a pretty complex web. From framing the initial business problem, looping through feature engineering, evaluating the model, and constantly checking feedback loops for retraining, it can look a little overwhelming at first glance. But don't worry, we can easily distill all that complexity into 5 core phases. First, data collection. That's gathering your raw material. Second, preparation and cleaning, filtering out the noise and structuring that data so it's actually usable. Third, model training. This is the heavy computational lifting where the patterns are actually formed. Fourth is evaluation, testing the model's accuracy against brand new data. And finally, step 5, deployment, pushing that live model into a real-world environment.
Which brings us to our final stop today, Section 5, Real-World AI Impact. Now, what's really interesting about this slide is seeing what happens when these models are actually deployed. They cause massive, disruptive industry shifts. In the automotive world, we have systems like Tesla's autopilot utilizing computer vision and reinforcement learning to navigate complex, unpredictable roads. And in healthcare, we are seeing incredible strides in AI disease diagnosis. We're talking about predicting health issues and personalizing medicine before a human doctor even spots the symptoms. To see just how localized and high impact this technology can be, you have to look at Ubenwa. It's an AI-powered app operating in Nigeria, and it actually analyzes the specific acoustic patterns of an infant's cry to detect early signs of birth asphyxia. By training a machine learning model on thousands of audio files, this app provides life-saving early intervention in regions that might completely lack access to full healthcare facilities. I mean, that is inference actively saving lives. Incredible, right?
And the impact stretches across critical infrastructure too. Take M-KOPA. They leverage AI to predict user payment behaviors, which allows them to offer affordable pay-as-you-go solar power to off-grid households in East Africa. Or in Ghana, where Syecomp uses AI-driven geomapping to give farmers highly localized weather and agronomy advice. These companies are taking massive data sets, training robust models, and outputting tangible, sustainable energy and food security.
So I want to leave you with a bit of a provocative question today. Based on the mechanics we've just covered, from data collection straight through to inference and deployment, how will machine learning reshape your own industry in the next decade? The data is out there, the models are training, and deployment? Well, it's happening right now.
Thank you so much for joining me on this deep dive into the foundations of artificial intelligence and machine learning. Keep exploring, keep questioning, and I'll see you next time. This lesson is brought to you by The Andrew Academy.